So let's get started with our Day 2 labs. The first lab that we have here, I believe it's on page 24, is dealing with switches and other network systems. And this particular lab, we're actually going to be looking at some technical things rather than digging into configurations and things like that. But we will return to the configurations later on when we're dealing with firewalls, because we're actually going to use the same tool to look at those configurations. And as was pointed out during the class, the actual configuration for things like the management, the logging, the time synchronization, the banners, all of that stuff is really done the same way. So we'll just deal with it one time. In this piece, though, it's going to ask us first to get installed this tool called Wireshark. So let me go to my tools location. So on my computer, that's in my C drive, under tools. And inside of there, let's see here, network auditing, that's where it's located. And I can see the two different installers. Now what it does tell me to do here is to install the one that is appropriate for my system. Since I'm using a 32-bit machine, whoops, I'll install that one. And pretty soon I'm going to get tired of retyping that password, and I'm probably going to add my account into the local administrators group, just like I was supposed to beforehand. Let's see here. And I'm going to accept all, let's see here. Choose the features you want to uninstall. Oh, forgive me, I've actually already run through the installer. So usually I prefer to do that with you, but I forgot that I've already done it here because I actually used this particular machine when I was creating the labs. So just follow through the directions there, accept all of the defaults, and you will get to a point during the installation when it pops up another window. And now this is what it's talking about there on page 24 and 25, and start prompting you about a tool called WinPcap. You need to install that. Even if we're not going to use the sniffer to scan a live network, you still have to have WinPcap installed, or it's just not going to work properly. So let's imagine that I've actually followed those directions properly, and I've now got my Wireshark installed. So let's get it running. Over here I can see my Wireshark icon in my wonderful Metro interface. Let's get that up and running here so that I can match where we are on page 26. Now when I do that, I've actually got a few recent files that are visible here that you don't have, just because I've run this tool before. But your screen will probably look exactly like it does there on page 26. Mine is more or less the same. To use the tool, the first thing we're going to want to do is open up a file that comes on our DVD called sample. Now to do that, we could pull down the File menu and choose Open. We could also, right over here, click on the, let's see, where is it here? Oh, the Open item. So it really doesn't matter how you get to it. Once you're there, what you're going to want to do is browse to that DVD. And inside of the DVD folder, what it tells us on page 26 is that there is another folder named Configs. Now I know that's not doesn't make the most sense. However, for our purposes, it made sense to put all of the files we deal with in Day 2 right in one folder. And the majority of these really are configuration files. So here's our sample file. I'll click Open, and when I do, I instantly begin to see packets showing up in my interface here. Now let's just take a few moments and explain what it is we're seeing. And this is actually happening in the workbook on page 27, 28. I'm going to just pull this top piece down a little bit. At the top, it's showing you all of the packets that have appeared on the network. In this case, all of the packets within the sample capture. So the top you could view as sort of a network level view of everything that's happening. What about the other windows though? Well, notice right now that this particular packet is highlighted. It's a packet that's coming from some kind of a VMware host, going to broadcast, and it's an ARP packet saying who has this IP address, please tell this host. Now, if you don't know a lot about how sniffers work, this is actually a wonderful sniffer to learn a little bit about network traffic and sniffers with. Let's explain a few of the things we're seeing. Here on the left, under Source, note that it's telling us that it's a VMware system. Now, it turns out that when I have highlighted something in this window, the window right beneath it, the center window, is showing you the actual packet. So if you watch down here while I click a second packet, you'll see that everything down here changes. Let's go back to that first one. So it says here VMware. What's that about? Note down here that I'm looking at an Ethernet 2 packet, source VMware D5, so that's what we see up in the top. But then right here, it shows me something in hexadecimal. What we're looking at here is the MAC address of this packet. In fact, we're looking at the source MAC address, the machine that sent it, and we're also able to see the destination MAC address, where it's actually going. Now in reality, within the packet itself, these bits, these pieces, are actually not in that order. Let me break this open. So I'm now looking inside of the Ethernet 2 header, and let's click on the destination piece. Now you may note that as I click on things, you see things changing down here in the bottom. So the center window is showing you the protocol decode of all of the different layers within the packet, but the bottom window is showing you the actual payload. Now, it would be called the binary payload, but since it's being displayed in hexadecimal, we'll say it's the hexadecimal payload, but it's the actual content of the packet. And when I click on something here in the headers, like here, the ARP 80806, that's what makes this an ARP packet, or on the padding, this stuff over here that makes it the minimum size required for a packet, it highlights that in the bottom window. So just an interesting thing to note is that the source address actually shows up as the second address, and the destination shows up as the first address. Not important that you know that, but kind of interesting. You could think of it as maybe people or pilots on the radio who are talking to the air traffic controller. When they begin to talk, they would say, they would actually start with who they're talking to. So the pilot would say New York Center and then Delta 188. So New York Center is his destination. He's getting their attention. Then he says who he is. That makes sense with human beings because the human being needs to hear that initial piece that says, oh, I should pay attention, and now I know who I'm talking to. For the computers, the answer is much, much simpler. The reason we do it is because the hosts themselves watching packets on the network, they need to find out if the packet is for them. And the fastest and easiest way to make that happen is to make the very first 6 bytes the physical address of that computer. Now it knows if it needs to look at anything else in the packet. So mathematically, it's just the simplest place to locate the data. In any event, when we look at this, this source address, we see 000C29 D5CBFF. And if you observe here, you can see the D5CBFF. So this part, that is actually identifying the machine, while this part here, these 3 bytes, are known as the OUI, or Organizationally Unique Identifier. And our sniffer is saying, well, those 3 bytes mean this is some kind of VMware machine. Whereas this one here, it says that's some kind of a digital equipment system. So just looking at the first few bytes, it can say, oh, that's an Apple computer. Really interesting information that we can use later on, perhaps, when we're looking at wireless or other things, trying to determine if there are unauthorized systems on our network. Because we can look at that value and see if the kind of network card is the kind of card that we actually use in our network. All right, so at this point, we've actually discussed the different kinds of windows here and what's actually available in them. Let's try to go back a little bit and look at what the lab is asking us to do. I'm looking on the bottom of page 27, and it appears that they're getting us ready to create a filter. Now, to do that, we could actually, excuse me, we could actually type the filter right in here if we're familiar with the Wireshark filter language. But if we're not, we can use this expression button, and that's actually what we ask you to do in the lab. In the lab, we're trying to get you to see all of the kinds of features this tool has. And as I scroll down here, you can see that there are many hundreds of different protocols that this particular system supports. Right now, though, we've been asked to identify TCP traffic, so I'm going to scroll up here until I find TCP. Oh, there it is. And if I open that up, you can see that I can actually search for things or create filters based on anything that could have to do with TCP packets. In my case, though, I just want to find all of the TCP packets. So I'll say TCP is present, OK. And when I do, it adds this little filter up here. Now, if I did something more complex, it would of course include all of the rest of that data. TCP source port is 80, it would write that all out for me. Just putting that filter in there though doesn't actually change anything. You can see that all of the data is the same. All I need to do is either press the return key or click on the apply button. And when I do, I am now instantly looking at just the TCP data. Now let's look back at the workbook and see what it wants us to do next. So we're looking at the TCP packets. Yes, I can see here TCP, though there are a few that are something else. I see HTTP here. However, if I look down in the bottom, I can see that that is actually a TCP packet. It just happens to be holding or transporting an HTTP packet or a web request. Now, the next couple of pages here on page 29 is asking us to take a look inside of this so that we can see where the different aspects of the packet are, working through what we just did as we were doing a little exploration. So let's just run through that quickly. It asks us first to find the TCP portion here. Let's break that open. And I'm actually not sure I'm on the right packet here. It wants packet 18, so let me switch to that one. There we are. And inside of here, I think it asks us to find, let me find it here. Oh wait, no, I'm sorry, packet number 21. I was on the right one. Let's see, click on the plus sign for TCP protocol item, and we can see all of the aspects of it. We can see the source port and the destination port and all of the rest of those things. And if we now were to click on the port number, I can see it right there, 0050. If we were to, let's see, click on the flag section of, I feel like I'm looking at the wrong packet because I'm not sure it lines up. Let's see here. Oh no, it does actually, pushak. So 8018, that's exactly what I'm supposed to see. So just walking us through exactly what we just did a few moments ago. All right, that's great. I can look in and I can see what a packet looks like. You might be thinking to yourself, hey, I'm an auditor. I don't really care what a packet looks like. Why are we doing this? Let's just show you one or two other things about this tool that explain why something like this and knowledge like this can be so valuable. Let's right-click on this packet. Now, I'm still dealing with packet number 21, right-clicking, and this is exactly what it's saying on page 30. I'm going to tell it to follow the TCP stream. Now, before I click on that, you'll notice that it also has options to follow other kinds of streams. Now, those are not available because they are not that kind of stream. And in fact, UDP, it's even questionable if that's a stream protocol. However, what this means it will do is design, let me just scrote this out of the way here, it will design a filter that will find that conversation. And in the top here now, I am only going to see packets that are related to that conversation. They're all filtered out. And it would do the same thing with UDP and other kinds of protocols. With that done, I now have a wonderful thing. I can now see all of the content that was sent from the client to the server. That content is highlighted in red. And I can see all of the content that the server sent back to the client. And that down here is highlighted in blue. Now, when it shows me this data, I might look at this and say, well, that's interesting. What is that? I can't read it. The reason is I can see right here that this is zipped data. If I were to browse around and find something that was not zipped up, maybe if I could find an image file, let's I switched this here to be stream number 2. Let's see, that's asking for a CSS file. That's just fine. Let's follow the stream. And again, it's gzipped it. So what's happening here is this web server is zipping everything so that it can send it in a much more condensed way. What I could do with this if I'd like to is I could actually extract just this binary content and I could save it out. Once I've saved it out, I could now modify that, maybe even parse the data. So for instance here, I can set it to only show me the stuff that came from the server to the client, and I'm currently set as raw. Let me try to save that. Rather than getting distracted with that though, let's move on to part 2 of this and see what it is we're really here to find. Now you'll find that on page 31 under part 2, we've been looking at this sample2 capture file. Or sample capture file. Let's close that up. So File, Close. And there is actually a second file in that folder that we're interested in. It's the one labeled Layer 2. So let's open that one up. Now, I still have a filter set up here. Now, this is just because I had a filter set before, so it's zeroing in on some kind of a conversation that's happened in my data. Let's clear that so that we're looking at all of the data, and I'll just make sure I'm up at the top. Yes, I am. What we'd like to do is two things. Let's illustrate a really important thing that network engineers and security engineers ought to be doing periodically on our networks. One of the things that they ought to be doing is verifying that only network traffic that we know belongs is actually appearing on our network. How can they do that? Well, in the lab there on page 31 and 32, we start working you through this problem. Here's essentially what we'd ask them to do. We would ask that network administrator to look at a packet capture, perhaps even a live capture on his network, and try to identify all of the traffic that does not look familiar. For example, let's start with saying, I want things that are IP, so that will show me all of my IP packets. Well, actually, we're dealing with layer 2, so I'm going to say not IP. When I say not IP, now there could be other layer 3 and above protocols in here. I could have IPX, SPX, and all kinds of other things happening. But the majority of our networks will be IP networks. So when I say not IP, I'm excluding all of that traffic. Now for an administrator working through this, we would actually want him to be much more selective. We'd want him to look at a packet and say, for example, oh, let's see here, ARP. ARP is used to do the mapping between a machine's IP address and its MAC address. We absolutely need that running on our network, and we know why it's there. So if I know why it's there, I can identify it, and not ARP, I would add it to my filter. And progressively, we're asking him to trim out everything that he can identify. So rather than the administrator starting with not IP, he would probably be starting with not TCP port 80, not UDP port 53, identifying things in the capture that he can explain. For us, though, looking at layer 2 issues, we said during the class that one of the easiest things that we can do to determine if our switch is misconfigured is look to see if we see layer 2 management protocols being sent out of switch ports that users are connected to. What we're talking about here are things like VTP or HSRP or TRILL or STP or MSTP, any of those layer 2 management things that are used to either control how things are bridged or to control how VLANs are managed. I'm of course using some of the more Cisco-specific lingo, but if we were using HP, we would be looking at the protocols that that system uses. The naming is a little bit different, but the protocols actually do essentially the same thing. Well, let's see what we see now. I can see that there is some kind of traffic here that most administrators would have a little bit of difficulty identifying. In this case, we're looking at a DEC VAX cluster. This is actually called DECnet. Now, DECnet is particularly to our network, the network where we collected this, because we actually have a VAX cluster here, and it's using DECnet for doing its clustering. So for us, we could identify that and say, yeah, I know what that is. I'm going to filter it out. Now, I'm not going to, well, if I add this in here, let's see. Yeah, I could do that, and we could add to it, and not IP, and not ARP. There we go. So I can get that stuff out of there. There still is a little bit more going on. I can see this DECnet phase 4 traffic. That's fine. It's the same sort of thing. We're not really trying to do this kind of analysis, though. In other words, the engineering analysis. What we're interested in are just those layer 2 management protocols. So for us, we're looking for things like spanning tree and others. And if I look right here, I can see, look at that, spanning tree packets. There is actually another curiosity here. I want you to notice that our spanning tree packets are encapsulated as 802.3 packets, whereas our DECnet packets are encapsulated as Ethernet 2. It's actually a different way of encapsulating packets. So So these are 802.3. This is an 802.3. This is an Ethernet 2. It's an interesting thing to note, because if we're finding multiple encapsulations, everything will work just fine, but you can actually run into devices that are not happy when you have different encapsulations occurring. For us, though, again, we're primarily interested in those management protocols, so here's what we're focused on. I've got spanning tree protocol visible on a client segment, and, well, let's see, what is this? My goodness, it looks like it could be CDP or VTP or DTP, or these are all layer 2 management protocols that are either for distributing information about Cisco configurations, CDP, or dealing with VLAN trunking or domains. In this particular case, looking at the destination, it looks like it could be any of those, but it's actually being identified here as CDP, and I can see that here as well. This is actually CDP. And if I scroll down, it shows me information about it. Interesting. Stuff that I should never, ever be able to see as a user sitting on the network. Now, I want to be clear that this collection of information was done just connected to an Ethernet port on the switch. There were no attacks run against the switch, nothing, and it was just a standard user port. It's actually, unfortunately, extremely common to find this kind of misconfiguration. With these ports turned on, with these protocols turned on, it's possible for me as an attacker to use a tool like Yersinia or others to begin to try to take over the spanning tree. If I take over the spanning tree, I can control the paths that all of the packets will take while bridging through the network. That's very serious. Additionally, it allows me to route packets, or bridge packets to myself. It also tends to imply that if I were to come up and begin advertising that I was a switch using spanning tree or other protocols, the switch would agree to allow it to trunk data to me, allowing me to now capture data from any VLAN I'd like to. Very serious. Coupled with other common configuration issues like lack of a VLAN trunking protocol password, that would allow me to take over the entire VLAN, even reconfigure it. I could even just subscribe my computer to indiscriminate VLANs, allowing me to see and participate in networks that normally I would have no access to. So this actually is a very, very serious finding. You may look at this and say, well, I can see how important that is, but this seems like it's kind of a hard way to do it. Is there an easier way? The answer is yes. Let me clear that filter and go to the statistics menu. There are actually several things in here that can be quite useful for finding this information. Let's just take a look at the protocol hierarchy. In the protocol hierarchy, if I open that up, it shows me all of the different protocols that showed up. This is actually a much easier way for us as an auditor to approach this problem. Because now I can see, well, let's see, Ethernet, yeah, there's supposed to be Ethernet. Now I'm looking at logical link control. This is layer 2 management stuff. And I can see that I've got spanning tree packets, Cisco discovery packets, and we haven't discussed routing and protecting routing information yet, but I can see that RIP is apparently being used, which tends not to be a very secure thing to use. There are other things happening. For instance, I can see my DECnet protocols happening down here, but I can just zero right in on the things under the logical link control and then investigate which of those are appropriate for my network and whether or not I should see them coming at me from a client port. Again, in this particular situation, a very serious misconfiguration. That brings us to the end of this particular lab, but remember, we are going to revisit these switches because we need to come back and look at a way to look at the configuration for common errors, to see whether or not the switch ports are locked down, to see how the VLANs are configured, and the rest of those things. And rather than reading through that particular configuration line by line, there is an easier approach to that problem. So, more on that later.